So let's continue with what we just were doing on the other page. We already took a 9 out of this to give me x squared minus 9 equals 0. And again, that was that first step using the GCF. And now I want to show you the difference of squares pattern. And the difference of squares pattern says if you have a perfect square minus difference minus another perfect square, that it factors easily into a plus b, which is the square root of the first plus the square root of the second, a minus b, which is the square root of the first minus the square root of the second. So why do I bring this up? Well, because x squared is obviously a perfect square. What's the square root of x squared? X. 9 is a perfect square because the square root of 9 is 3. So how am I going to factor this? I still have my 9 on the outside, but what I'm going to be left with is the square root plus the square root, so x plus 3, and then the square root minus the square root, x minus 3. So that is factoring completely, and now of course I would set these equal to 0. Notice, do I need to set the 9 equal to 0? No, because 9 doesn't have an x with it. We only care about the x's. So I'm going to say x plus 3 is equal to 0, so x is negative 3. X minus 3 is equal to 0, so x equals 3. So those are my two solutions, are negative 3 and positive 3. Same thing with the second one. This one I didn't have a GCF to take out, but the perfect, or the square root of x squared is x. The square root of 121 is 11. So it's x plus 11, x minus 11 equals 0. And that gives me x is negative 11 and x is positive 11. Now, you might be saying, well, come on, Professor Brame, I could just do this. Add 121 to each side, take the square root, and I get plus or minus the square root of 121, which is plus or minus 11. Notice I get the same answer either way. So the answer is yes. Instead of using the difference of squares technique, if you're solving, it's perfectly acceptable to solve. And this only works when there's no middle value. So if I had like a 2x in the middle, that wouldn't work anymore. But since I don't, this works just fine. And you get the same answers as long as you remember that when you take the square root in an equation like this, you got to have your plus and minus.